Bismillah ar-Rahman ar-Rahim. Inshallah, we'll do section 4.8. Then I'll try later to finish the remaining of the other sections. Like 4.7, I think also 4.6. Some of the sections, I left some of the exercises, but now let me do 4.8, which is the last section. Linear approximations and differentials. Okay, what's the meaning of this linear approximation? If you look at this graph, assume I know what is f of a. F of a is known, I can do it, can calculate it. I don't need calculator, it's very easy to do. But I don't know what is b. I don't know what is f of b. F of b is this one, but I cannot calculate f of b. For example, this is 1, this is 1.1, which is difficult to calculate using I need the calculator to do it. So instead of finding f at b, if you notice the tangent line, which is this one, if I want L at b, which is a linear function, so it's easy to calculate. I mean, L of b is easy to calculate. And the error, the difference between them is almost negligible. I mean, it's very small, so we can't neglect. So instead of finding f at x, I will approximate it by this function L of x, which is just the tangent line. This is just the tangent line. So L of x is what? This is the formula for L of x. So this is also, they call it the normalization of f. They call it the linear approximation, tangent linear approximation. All of these are the same. So instead of finding f of x, I will find L of x. Notice x equal a is the center of the approximation. If I go far from a, then the error will become bigger and bigger. Okay. The same idea will apply to something called differential. What is the idea here? Assume there is a change of x. I assume I have a function, differentiable function. A change of x, we denote it by delta x. Change of y, we denote it by delta y, which is f of x, and this is, I'm going from x to x plus delta x. I'm going from here to here, change it from x to x by this delta x. So it will be change of y, f of x plus delta x minus f of x. Okay. We define something called the differential of x and denoted by dx. And that dx is the same as delta x. This is like a tradition. This is the way they started with. We define the differential of y, which is dy, which is equal to what? F prime of x dx. Notice in f prime of x is dy over dx. So just to make things are easier to deal with. Okay, so this is the way they define the differential dy, which is f prime of x dx. Okay. The idea is to find delta y for small delta x 0.1, 0.2 or something very small. It will be very, very difficult to calculate. You need a calculator to do it, to plug the number, do all of these things. So if you notice from this graph, this is delta x. So this is f of c, which is this one. This is f of c, which is this one. And this is f of c plus delta x. So this one is delta y. This is my target. My target is to find delta y or to approximate it. Also, if you notice from this is the graph, and this is the tangent line. The same idea, exactly. This is f of c. This is c. And this is c plus delta x. So this is f of c plus delta x. If you notice this distance is f prime of x delta x. Why is that? Because this is tangent line. I know that the slope of the tangent line is f prime at x at c. I mean f prime at c, since I'm using c. F prime at c. This is the slope. The slope is delta y over delta x. And this is my delta x. So this is delta y, which is f prime of c delta x. So approximate delta y by dy اللي هو f of x dx at c or at x. Okay. So this is the idea. I will approximate delta y by using this small d, y. So from here, f of x plus delta x will be what? F of x plus delta y, take f of x to the other side, which is approximated by f of x plus dy. So the differential approximation, usually they wrote it like this, f of x plus dx. Notice usually we put delta x as dx is the same as delta x. Okay. So we get this linear approximation, which is the same as what we did before. So these two are different. This one, just to tell you, that the error is very small. We can neglect it, especially if I am around A. Okay. As it takes very small, which means we are around A, or around C in this graph. So the results, I mean, these two are all the same. Okay. Now, actually, we're talking about an error in the calculation. We are approximating what's going on. Have a differential and y changes, x changes from x0 to x1, and y changes from y0 to y1. Like in real life, if you have, for example, square table, for example, usually the sides, the length of the sides are not accurate. So usually we get them with some error. So assume this is x and this is x. This x is not accurate. So there is an error in them. So that error, if I want to find the area, which is f of x, which is x squared, the error in calculating x, where x is not 1 exactly, maybe it is 0.995, something like this. So there is an error in finding that. The error will propagated when I calculate the area. So instead of dealing, so I now I want to know what will be the error of the difference. Assume x is changing from, as I said, but from 1 to 0.995 to x1. There is an error. Usually we make it x0 to x1. We say changes from x0 to x1. So y change it from y, which is what? What will be delta y? The difference in y. That will be the error in y, which is f of x1 minus f of x0. Which is, we agreed before, that can be approximated by this one. So we have the absolute change, which is the error. And also we have the relative error, which is what? Delta y over y0. And that can be approximated by dy over y0. Actually, I'm expressing delta y by dy. The percentage error, which is dy by d0 times 100%. And this is the table explain everything. This is the absolute change. There's an error in x. So this will be the error in y. And this is the relative change. And this is percentage change. And these are the estimated ones, where I make delta f approximated as df. Okay. So this differential, it's somehow, I can't deal with it in this way. Let y and v be differentiable function. So the differential of c times u, it will be c du. Like in this one, if I have x squared, for example, this is the derivative, but this is the differential. And now we can apply it for any function. So we have mainly the linear approximation, which is this one, which is the main thing. And also the same idea with the differential to approximate delta y in this case. Here we're approximating the value of the function at a specific point, but here I'm approximating the delta y, which lead me to the errors. I have absolute or relative error, percentage error. And also we define the differential, we try to explain it more, the differential formulas, which is the same formulas which we did before, but you need the d every time. Okay. Okay. Now let me do some problems. These are the three things. Linear approximation, differential, and the errors, and how the error propagated when you calculate the value of the function. Find the tangent line approximation of this function. This is an easy one, which is I'm looking for this one. So my L of x is f of a plus f prime at a x minus a. Okay. So this is my f. What is a? A is 0. This is my a. Okay. So f of what will be f prime at x is cosine x. What is f at a? 1. F at 0, a, it will be f at 0, which is 1 plus 0, which is 1. F prime at a, it will be f prime at 0, and that will be 1 also. So L of x, it will be what? F of a, which is 1, plus f prime at a, which is 1, times x minus 0. So it will be 1 plus x. That means what? Sine x approximated, I can approximate it using 1 plus x. I mean 1 plus sine x. I can approximate it using 1 plus x. Near x equals 0, which is fa 0. Okay. That's mainly the idea. So I'm approximating this function using a linear function. So if I want to find f of 0.1, which is 1 plus sine 0.1, I cannot find this. I need calculator to do it. But this is, I can approximate it as 1 plus 0.1, which is 1.1. As I said, this is accurate as we are near x equals 0. Find the generalization of this function. Same idea. Let's find f prime. That will be 1 over 2 square root x plus 1. What will be L of x? Will be f of a plus f prime at a, x minus a. That will be f of 0, 1. F prime of 0, half x. So this function, I can approximate it using this function. Near x equals 0. Yeah, I think I can put some numbers here. Let me see if I have the calculations. Make it very clear. So notice, for example, fx equal 0.2, for example. What you have, I have a square root 1.2, which is 1.095445. Okay. I want to approximate it. Approximate by 1 plus 0.2 over 2, which is 1.1, which is almost the same. If you notice, it's almost the same. Also, if x equal, let me put another value, 0.5, the 0.05. Yeah, make it very small, 0.05. The result, if you do this, 1.05, calculator is 1.00, 0.02, 4695. If you approximate it by 1 plus 0.05 over 2, that will be 5 over 200. That will be 1 over 40, which is 1.025. Almost the same. Almost the same. That's my lead idea. Okay. And you notice here, when I am very near to 1, I'm getting almost the same. But when I go a little bit farther, now the error becomes a little bit higher. Finalization of this function at a equals 60 degrees. Notice here I have 60 degrees. So first, since I'm doing the calculation, I need to change everything into radian. So what is f prime? That will be cosine x. What is f prime? No, I need, what is f? What will be L of x? L of x, f of a plus f prime at a, x minus a. My a is 60, which is pi over 3. I'll deal with everything in terms of radian. Okay. So f of 60 degree is f of pi over 3, and that will be sine pi over 3, which is square root 3 over 2. F prime at 60 degree is f of pi over 3, which is half. So L of x will be what? Square root 3 over 2 plus half x minus, I will not write 60 here. I'll write pi over 3. Okay. That will be my L of x. Now, sine 61, which I want to approximate, sine 61 degree, that will be sine 61 pi over 180. We know how to convert those into radian measurement. Multiply by pi over 180 if you forget it, which is L approximated. I can approximate it using L of 61 pi over 180. Since I know that in f of x, I can approximate it using L of x near x equal pi over 3. Which is what? This one is square root 3 over 2 plus half this number, 61 pi over 180. By the way, this is, you can think of it 60 pi over 180. Easy to do the calculation. So I'm getting what? Square root 3 over 2 plus, this is pi over 80. It's plus pi over 180 times 2, which is 360. So that will be the approximation of this. Okay. Let me do more. more problems. Find the initialization of this function, square root x plus 3, and use it to approximate the number square root 3.98. Okay. So I have here f prime 1 over 2 root x plus 3. Okay. F of 1 or f of a is f of 1, which is 2. And f prime of a, which is f prime at 1 over 4. Okay. L of x is f of a plus f prime of a, x minus a. That will be what? 2 plus 1 over 4, x minus 1. Which is what? X over 4, 2 minus 1 over 4 plus 7 over 4. So I can approximate f of x. I can approximate it by L of x. Okay. Now we'll come to this. Square root 3.98. I want to check. This is f of what? That means I need x plus 3 as 3.98. So my x will be what? 0.98. So square root 3.98 for this function, it's f of 3.98, which is, I can approximate it using L 3.98. Yeah, L, not 3 point, L, this is f of, sorry. This is my x, so it's f of 0.98. Note the function is x plus 3, huh? The function is x plus 3. And this is, I can approximate it by L of 0.98. And that is what? That is 0.98 over 4 plus 7 over 4. If we do the calculation, that approximately 1.995. Now square root, using the same idea, this is f 1.05, which is approximated by L 1.05, which is equal to 1.05 over 4 plus 7 over 4. And that is 2.0125 as a calculation. Okay. Also, sometimes they are using the words overestimate or underestimate. Huh? What's the meaning of that? If, for example, in this one, you have what? You have this. You want it at a equal 1. And this is your approximation. So your approximation is more, our approximation is more than the exact value. So they call it overestimate. It's more than our estimate is more than the exact value. However, if the function going the other way, if the function going the other way, and for example, the function is doing something like this. If you have a function going like that, have space, that is, let me put it here. I have a space here. So if you have a function like this, so your estimate, assume this is done, your estimate will be less than the exact value. So they call it underestimate. That's if you saw the words overestimate or underestimate. That's the meaning of it. Okay, let me do more problem. Now we have the second part, which is I want to approximate delta y using this small dy. Okay. Now we have y equal x square. I want to approximate it using this delta y. Like the complete numbers, accurate number. Okay, the correct numbers. Okay. I have x equal 1. This is the x, which is delta x. As we agreed, dx is the same as delta x, which is 0.01. Okay. Compare this value with delta y. Delta y will be f of x plus delta x minus f of x. That will be f of 1.01. This is 1, and this is 0.01. So 1 plus 0.01 minus f of 1. If we do it using the calculator, that give me 1.01 square minus 1 square, and that exactly 0.0201. Okay. Now my claim in the delta y, I can approximate it using dy, which is f prime at x dx. What is f prime at x? Now let me check here. F of x equal x square. That means f prime of x will be 2x. That will be 2. Okay. Now x equal 1 and delta x is 0.01. So that will be f prime at 1 times 0.01, which is f prime at 1 will be 2.01. That is 0.02. Look at this and this. They're almost the same. Compare another example of delta y. If this, then this. Okay, more examples. Who cares? Okay, let me do more examples so to make it clear. Okay, I need f prime. Okay, I have delta x. It's changing from this to this, so delta x is 2.05 minus 2, which is 0.05, and this is equal to dx, small dx. Okay. Delta y will be f of x plus delta x minus f of x, that f of 2.05 minus f of 2. If you do it using the calculator, let me plug the numbers. Don't want to waste my time. Yeah. If you do it use the calculator, we're getting this minus this. I plug 2.205 here and 2 here. I mean, I'm doing the calculation. I'm getting 0.717625. Now my claim is I can approximate delta y using dy, which is f prime at 2, my x is 2, times dx. F prime at 2 is what? 3. That will be 12 plus 4 minus 2, which means 14. Yeah. Times dx, which is 0.05. That will be 14 times 5 over 100. That is 0.7. Look at this. Now another example, the same thing, but will be f prime. Let me write it again. We'll do the same. That I have x equal to delta x is 2.01 minus 2, which is 0.01. I expect the error to be better since I am near to 2. Delta y, we do the calculation, it will be f of 2.01 minus f of 2. Do it by the calculator, we're getting something like this, 0.14 0.0701. So my claim to delta y, I can approximate using dy, which is f prime at 2 dx. My delta x is 0.01, which is dx. This is dx. So this is 14 times 0.01, which is 0.14. Look at this. They're almost. Okay. This function, the same idea, find formulas for delta y and dy. And to find formulas for delta y and dy. Okay. This is f of x, and then apply it. Huh? F prime will be what? 6x minus 4. Okay. What will be delta y? You have x, you have delta x, which is dx. And delta y will be f of x plus delta x minus f of x. If you want to do it using the formulas, that will be what? I need to find this, apply instead of x plus delta x. That will be 3x plus delta x squared minus 4x plus delta x plus 5. This is only this, minus 3x squared minus 4x plus 5. Now, if you do the calculation, that will be what? 3, you have x squared plus 2x delta x, correct? Plus delta x squared minus 4x minus 4 delta x plus 5. All of this is minus 3x squared plus 4x minus 5. لحد هذه cancelled. These things cancelled. Also, this one will be cancelling, will be cancelled with this one. So you have what? 6x delta x plus 3 delta x squared minus 4 delta x. This one will be cancelled with this one until that I think. Okay. Notice this function of delta x. So if delta x is very small, if delta x goes to 0, delta y will go to 0. And this is what we usually have. Now dy, this is delta y. dy easily f prime of x dx, which is what? 6x minus 4 times delta x. Our claim in this one, I can approximate it using this. Let us apply it for these things. X equal 3, delta x equal 0.01. What will be delta y? Part B, this is part A. Part B, delta y, if you do the calculation, plug the numbers, plug x equals 3 and delta x equal 0.01, use the calculator to do it. It will be 0.1403. dy is 0.14. So very clear, delta y can be approximated by dy. Okay. More examples. Then using this, then we'll go to the error. Okay. Compare delta y and dy where delta x equal dx. Okay. This is the function. I need f prime, which is minus 16 or over x squared. I have delta x is minus 1. So delta y will be f of x plus delta x minus f of x. And that f of what? 4 minus 1 minus f of 4. So it's f of 3, which is what? That will be f of 3 minus f of 4. And that is 16 over 3 minus f of 4 minus 4. So it will be 16 minus 12, 4 over 3, which is 1.3333. Okay. dy will be f prime at 4 dx. F prime at 4 will be what? Will be minus 1 times delta x. I know that in the delta x here dx, or dx equal delta x. Dx equal delta x, which is equal to x. That will be f prime at 4, substituting f prime at 4, will be minus 16 over 16, which is minus 1. That's minus 1 times minus 1, and that is 1, which is almost the same. Okay. Use differential to approximate this. Now, I want to approximate the square root of 80 using the idea of the differential. So I'll use which formula? Remember, when we talk about the error, or before that, we said I have this. And this is what we will do. So we have f of x plus delta x is the same as f of x plus delta y, where I can approximate it using plus dy, which is f of x plus f prime of x dx. I mean by x dA, huh? Okay. Think about the square root of 80. What is the function? What is the value where I can find the square root? For sure, I will do square root 81. So my a, for my function is square root of x. This is very clear. Example 6, who cares? And my a, which is easy to calculate, will be 81. So that implies in the square root of 80 is what? The square root of, that implies f of 80. The square root of 80. I can write it as square root of 81 minus 1. And this is, I will make it f of x plus delta x, or f of a. What is my a? My a is 81, and my delta x equal minus 1. Note, as we said, f of 80 is f of 81 minus 1. I want to apply this now. That will be approximately f of 81, I'm using this now, plus f prime of 81 times delta x, or dx. This is equal dx. So I'm just using the formula, f of x, let's write it here, f of x plus delta x. I can approximate f of a using f of a plus f prime of a dx, or delta x. That's my lead idea. So my a in this example is 81. This is 81. And this is minus 1 to make it square root of 8. So I have f of 80. Okay. So f of 80, I can approximate it by the, what is f prime? Let me do f prime. F prime of x, 1 over 2 root x. Very easy. Okay, f of 80 will be f of 81, which is 9, plus f prime at 81, plus 1 over 18. Dx is what? Minus 1. So it's 9 minus 1 over 80. Okay. Now, if I want to do example 9, let me do it quickly. What is my f of x? Very clear, cube root of x. What is my a? I need a value where I can find the cube root, which is near x, near 7. That will be it. That will be my a. Okay. Now, my claim, what is delta x now? Yeah, I want f of 7, which is f of 8 plus minus 1. So that implies in my delta x equal -1. So I want to approximate. I need f prime of x. Huh? F prime of x is what? 1/3 x is -2/3. So I can approximate f of 7. Can approximate it using this, which is f of 7, which is f of 8 plus -1. So this is a, and this is delta x, or dx. So that I can approximate it using f of 8 plus f prime at 8 times dx times -1. And that, what is f of 8? That will be 2. F prime of 8 is what? This is 1/12. Huh? So it's -1/12. Okay. Yeah, I can calculate it. That will be what? 23/12. Approximate this using differentials. Okay. So what is my function? My function is square root of x. My a, I want to find the value where I can find the square root. My a will be 121. Because I know square root 121 is 11. Okay. So I have f. I have f of 123, which is f of 121 plus 2. So this is a, and this is delta x, which is equal to x. Now we'll do the calculation. I need f prime 1/2 root x. So f of 123, which is, as we agree, is 121 plus 2. I can approximate it using f, using this formula, which is f of 121 plus f prime 121 times dx, which is 2 in this case. That will be what? 11 plus 1/22 times 2, which is 11 plus 1/11. Example 11. What is my f of x? Is ln x. What is my a? Near 1.1. For sure, I'll choose 1. A equal. So I have f 1.1, which is f of 1 plus 0.1. So this is a, and this is delta x, which is dx. So f of 1.1, which is f of 1 plus 0.1, I can approximate it using f of 1 plus f prime of 1 times 0.1. By the way, here I have f prime of x is 1/x. That gives me what? Ln of 1, which is 0. F prime at 1 will be 1 times 0.1, so it's 0. Okay. I think now we have good example about generalization, and then example about this approximating delta y using dy, and which is using the differential, and then I use it to approximate these values. Okay, let me finish by the errors to see how to deal with these errors. The radius of the sphere was measured, found to be 21 centimeter. This is R. Possible error 0.05, at most 0.05. So this is the error, which is dx. the error in X or the error in R. Make it the R. Okay. What we want, they want what is the maximum error, since it's at most, so I will use this number. What is the maximum error in using this value to compute the volume of the sphere? And the volume of the sphere is 4 over 3 pi r cubed. Is the volume of the sphere. So the error in V, I can approximate it by dV, which is what? 4 by r square dr. Well, like the number, you get everything. And that, so dV will be what? 4 times pi times 21 square times 0.05. If you do it, use the calculator, that will be 277. Okay. So this is the error in computing the volume, or the maximum, since this is at most, so the maximum error will be 277. Diameter of a sphere is determined to be 16 centimeter, with maximum error of this. Okay. The diameter. It's talking about the diameter, not about the radius. Huh? It's talking about the diameter. Be careful. Now, capital D is 16. And its error is 0.001. Use differentials to determine the estimate of the maximum error in computing the volume. Okay. So what is the volume of the sphere? Huh? A sphere, yes. The volume of the sphere, this is A, 4 over 3 pi r cubed. I want to do it in terms of D. I know D is 2r, or r equal D over 2. So plug it here. That will be 4 over 3 pi D over 2 cubed. That gives me what? This is 8 cancelled, so I have 1 over 6 or pi over 6 D cubed. Okay, so what will be dV? By the way, this is, we'll do it for all. So A, I want to estimate the maximum error. So this is the maximum error. So like dA, so I have dV equal what? Pi over 2 d square dd. Okay. Pi over 2 d square dd. Okay. So it will be the error, and that equal pi over 2 d square, which is 16 square. dd is 0.01. 0.01. And now if you do the calculation, you're getting 0.4. Is it? Yeah. Check it. Sorry, the error is not point. It's 0.001. Okay. Yeah, that makes sense. So this will give you 0.4 centimeter cubed. Okay. Now, if I want to find the relative error. Okay, relative error is what? dV by V. And if you do, try to simplify it. You have what? dV is this one, so it will be pi over 2 d square dd over pi over 6 d cubed. That give me what? 3 dd over d, which is 3 times 0.001 over capital D, which is 16. If we do the calculator, it will be something like this, 0.0001875. This is the relative error. C, the percentage error will be what? dV over V times 100 percentage. So I need to multiply this by 100. I have 0.01875 percentage. I think that will explain it. This is bound to be 9, so R equal 9. Accurate to within this, it means the error is less than 0.01. So I need the maximum error is 0.01. So I need to find the maximum in the volume. I know why all of these examples are about the sphere. Who cares? dV will be 4 by R square dr. And that will be 4 by 9 square 0.01. Do the calculation. That will be 32.4 by centimeter cubed. Yeah, I think. The measure is the ball is 0.5. The measured radius. This is R. I show in the figure. The measurement is correct to within kilo. So I have dx or delta x, which is delta less than 0.01. So the maximum error is 0.01. Okay. So I want estimate propagated error in the volume. Is also sphere. I know why all of these examples are about the sphere. Okay. I have 4 over 3 by r cubed. dV will be 4 by r squared dr. We do the calculation, that will be what? 4 by r is 0.7 square, and dr is 0.01. That's approximately 0.06158. Yeah, using the calculator. Okay. Now, as we said before, I can use differentials to do the calculation. So if y equal x squared, the derivative is what? dy over dx. Derivative means dy over dx. Huh? I do not write it every time. And then the differential. This is 2x. This is 2x dx. This is 1 over 2 root x. This is 1 over 2 root x dx. This is 2 cosine x. I'm talking about dy over dx. I have 2 cosine x dx. X ax, I have product rule, which is x plus 1 e to the power x. Huh? It will be e to the power x plus x. So I have here x plus 1 ax dx. I add only dx. Huh? This will be what? X to the power minus 1. So it will be minus 1 over x squared. And this is minus 1 over x squared dx. Here I have what? 3 cosine 3x. Here I have 3 cosine 3x dx. This will be half x squared plus 1 to the power minus half times 2x, which is x over x squared plus 1 to the power half. Don't forget the x. Use differential to approximate this. Let me finish my this question. I have the function square root of x, a is 16. I want to approximate of a plus delta x. I want to approximate يعني I have, this is, I want it to be 16 plus delta x. So my delta x is 0.5. Okay. So I want to approximate f of a plus delta x using this formula. But this is dx. Yeah. So f of 16.5, which is f of 16 plus 0.5. I can approximate it, f of 16 plus f prime of 16 times 0.5. And that f16 is 4. F prime of x is what? 1 over 2 root x. So it's plus 1 over 8 times 1. Plus 1 over 8 times. Yeah, 1 over 2, 1 over 8 times 0.5, which is 500. I want to see if that's, we can calculate it. I want to put the number. Oops. 0.5. If you do it using the calculator, that would be 4.625. Okay. Yeah. Let me stop here. Or can I do more problems? Yeah, let me continue until I reach the multiple choice questions. Okay. The diameter of a circular disk is found to be 30. I have capital D is 30. The error is this. With the possible error in the diameter, it's 0.2. Use the different maximum error to calculate the volume of the area of the disk. Circular disk. So the area, the disk is circular. So it will be the function will be pi r square. Okay. And I have the derivative is 2 pi r. Okay. No. Okay. First, I need to change this into diameter. That will be pi d over 2 square. So it's pi over 4 d square. Okay. So the area is pi over 4 d square. The differential of the area will be pi over 2 d dd. And that will be pi over 2 times 30 times 2 over 10. Cancel. That will be what? 3 pi. Okay. Ready? Will be pi over 2 capital D. Yes, this is 30. It's pi r square, which is pi capital D over 2 square, d square over 4. Okay. The approximation of this function at a equal 1. You want to find L. We know L of x is f of a plus f prime at a, x minus a. My a is 1. I need to find f prime of x. That will be what? A tan pi x times a tan pi x times what? Secant square by x times pi. Okay, so I have f of a, f of 1, tan pi is what? A tan pi, which is tan 0. That will be 1, a to the power 0, which is 1. F prime at 1, that will be 1. Secant square of pi, that will be also 1, minus 1 square times pi. So L of x will be 1 plus pi, that will be pi. I x minus 1, which is, yeah, that's it, I think. That's it. Approximate this. I want to approximate this one. Okay, so what is my function? Is x to the power 4/3. And what is my a is 27. A is 27. Okay. And to approximate this, I have f of, what is my delta x? Very clear. Is 0.3. 0.03. Sorry. 0.03. And what is f prime? Let me do it f prime since I need it. I have 4/3, x to the power 1/3. Okay. So we know that f or 27.03, which I want to approximate, f of 27.03, which is f of 27 plus 0.03. So this is a, and this is the x, delta x. That will be f of a. Let me write the formula here. F of x plus delta x, approximately f of a plus f prime of a delta x or dx. That will be f of a, f of 27 plus f prime of 27 times 0.03. Okay, that will be what? F of 27 is what? Cube root of 27, 3 to the power 4 is what? 81. 80. Plus f prime of 27, that will be 4, which is cube root 3. Yeah, that will be 4 times 3 over 100. So you have 81 plus 12 over 100. That will be 81.12. Okay. This is the change in y when x changes from this to this. So delta x is 0.001. I want to approximate delta y using dy, which is this quality f of x. So it will be f prime of x. It will be 3x squared plus 3. dy, which is f prime at 2, at a, this is my a, times delta x or dx. dx. F prime at 2 will be what? 15 times 0.001. That will be what? Yeah, 15 over 1000. Or if you want to make 0.015. 0.0. It's these things. Pi r squared. But the value is too big. Yeah. Since I'm dealing with the error, okay, but not the relative. Okay. 0.15. Okay. And approximate this. What is my function? Cubic root of x. What is my a? 32. What is my delta x? 0.08. 0.08. Okay. Once I know f of 32.08, I can make it f of 32 plus 0.08, and this is, I can approximate it, f of 32 plus f prime of 32 times 0.08. By the way, what is f prime? That will be 1 over 5, x to the power 4 over 5. X to the power minus 4 over 5. Do the calculation. F of 32, that will be 2, plus 1 over 5 times 1 over 16 times 8 over 1000. Yeah, very clear. Why 8 over 100? What is this? So this is 1, this is 2. So I have 2 plus 1 over 1000. So it's 2.001. Okay. Last question before I stop. I have, this is called f of x. F prime of x is 5x to the power 4 minus 10x plus 1. Okay. This is a. Delta x is dx, which is 0.001. So I want to approximate delta y using dy, which is f prime at 2 times delta x. What's f prime at 2? 5 times 16, that is 80. No, let me do this here. F prime at 2 will be what? 5 times 16 will be what? 80 minus 20 plus 1, correct? That will be 61. So this is 61 times 1 over 1000. That will be what? 0.06. Yeah. Let me stop. I think the rest is just the same idea, but different examples. Yeah. Stop the recording. Thank you.